Now we're going to introduce the panel. So I'd like to ask George if you can come back on screen and introduce the panelists.
Thank you, Dana. Indeed, for our next session, I'd like to invite our esteemed experts for a panel discussion. We have Richard and John already spoken, but I'd like also to invite Madeline, Professor Madeline Carr from University College London, Professor of Global Politics and Cybersecurity, and also Paul Waller, Head of Research at the National Cybersecurity Center. I think, Dana, in the interest of time, we might want to make a start whilst Madeline resolves connectivity and other issues.
Yes, I agree. Thank you.
So thank you very much. We're going to have a Q&A discussion with our panel and our experts, at the back end of which we will endeavor to get questions from the audience as well, time permitting. We are slightly behind time. When you post your questions from the audience, please make them clear and succinct. That will be much appreciated. Right, so we heard about this new technology, Morello, Cherry, digital security by design. One may ask Richard, what exactly is the proposition here? So John mentioned about vulnerabilities are in essence mistakes. So is this technology correcting mistakes? Is it putting an end to mistakes? What exactly is it doing?
Interesting question. I mean, I think Matt touched on the fact that software has mistakes in it. There are, billions and billions of lines of code out there, and a huge number of things essentially is assumed that, oh, when I go and talk to this array in memory, I will only my access into it will be within the bounds that are given to me, and or the bounds of the buffer rather, and I haven't got any problems. And people haven't thought about what happens if the pointer coming in is out of range. And these sort of mistakes exist throughout software. It's actually really quite remarkable when you start digging into it and use technologies that can look for these things, just how common it is that that essentially either memory is used after it's been freed up, or that accesses to memory go out of range, and all of those sort of things. And so turning around and saying, well, people should write software perfectly is just naive. In reality, there is so much software being written at any moment in time. There's always going to be mistakes. Human beings are inherently prone to creating errors, and we can't just turn around and say, it's your fault, you shouldn't do that. We need at the hardware level to be saying, well, if we assume there are going to be mistakes, how can we find them in the field, and how can we prevent them being exploited? Because what you have is this mistake is a vulnerability in the software, then some clever hacker finds a way to stimulate that so that they're then able to exploit that and gain access, gain a step towards getting access to the computer. For example, by going out of range on the stack, they're able to overwrite something that then when you do a return, you're able to select where you branch to. So yes, we're dealing with a world of mistakes, but we're dealing with the fact that across billions of lines of code, there will always be mistakes. And what hardware needs to do is be resilient in the face of that. And so the memory safety that you get out of Morello, out of the Cherry technology, is a key part of that. The other key part is that with the compartmentalization, the ability to fine-grain compartmentalization that we believe can be built from this technology, that when people are able to break out, to exploit a mistake like that, the amount of damage they can do is reduced. So that means that one little exploit doesn't give you access to everything that's going on. It gives you access to a much smaller thing. And that, I think Robert talked about, is raising the workload that has to be done by the attackers in order to be able to achieve any valuable endpoint. But this really is a recognition of the fact that the world cannot have perfect software, simply because there's just so much of it written, and people are inherently the push for time, the push for resources, they're reusing old software in slightly inappropriate ways. All sorts of reasons like that means these mistakes will always actually exist.
Sure. Thank you, Richard. I'd like to turn to Paul and ask about who is this technology for, and why would people want to use this technology?
So I think, excuse me, I think there's a lot of potential uses for it, and its strength is the sort of ubiquity of it. So the idea is obviously to make sure that in time, Cherry technology and indeed Morello technology becomes the right way to do things, and it becomes more usable the more widely available it is. But I think initially people interested in using it will be those who most benefit from the reduction in harm that Richard was talking about. So containing mistakes and vulnerabilities, making them more expensive or more difficult to get the same level of damage from. There's a lot of industries where there's interest in this now in order to improve the resilience of devices. So things like automotive, anything safety critical or medical, a lot of the industrial stuff, where there's interest now, but also more interest for future innovations. A lot of the things we're looking at doing more of along the lines of artificial intelligence, machine learning, connected places, and more wide scale access to big data resources requires a huge amount of confidence in the security of the platforms that we use. And it's up to us as a society to engineer that confidence and make sure that it's there and that people can rely on it. And we need to do that right from the ground up. And that's why I'm really pleased that an initiative like this one is able to start from the architectural level and empower that confidence all the way through the software stack.
Thank you, Paul. On the back of that, if I may turn to John now. John, what are some of the use cases that you are seeing in the program through the projects that you fund?
Yeah, it's interesting because obviously I think everybody's got the idea that we're fairly early on in the investigations and the prototyping, but one of the things we did in the program quite early on, as I mentioned in my talk, was expose this through the software model that Richard spoke about to a number of SME companies. And as a group, obviously it was new technology. Some of the questions we've had in the Q&A, can it be retrofit? Can I put it on a PCI bus? Missed the point that it's actually fundamental in the CPU to what's being changed here. And the projects, I think, ranged from a very thankful realization that they can actually catch third-party code vulnerabilities. So the idea that they just recompiled and actually now got a compiler flag, a compiler warning, well, I think it was a failure rather than a warning, that said basically this library that you're using has got a vulnerability in it. And they just went, oh, and that was just wide open. We had a couple of others that actually did manage to go into what does it mean to their compartmentalization. And they were doing some identity libraries for proving identity. And obviously the key thing there is to keep all the different parts of the code separate to each other. And they were very happy in the way that they could, build these distributed applications on a single machine. So really, the sectors that are going to go for this are the ones that care about security, care about the resilience of their solutions or the safety of their solutions, where in time, it'll hopefully become the de facto way of always building more secure technology solutions. So I think that's where we're at, is that who's it for? When it's for everybody who ever thinks they might use or build something on top of a computer, who will get there first? It's the ones that worry today about the resilience of their code, etc.
Thank you, John. Good to see you, Madeline. I hope we can hear you as well. Can we have a quick check?
Yes, sorry, George. I don't know what happened there.
Excellent. So Madeline, thanks for joining. In one respect, this technology can be considered arguably emerging technology, right? A new technology. And since it's not yet mainstream, how would businesses consider such an opportunity since it doesn't exist yet?
Yeah, well, that's a really good question. And there's a lot of work that's been done on how new technologies or emerging technologies are incorporated into the commercial sector. And there is often this kind of period that we're in now where we see a huge investment from government and a significant investment from the private sector to try and build this understanding of a business case or a commercial case for emerging technologies. I mean, this was very much what happened with the internet. If we think back, which was also funded significantly by DARPA, that the US government had put so much resource into that, really struggled to get the business sector to see that there was an opportunity for commercializing that technology, frankly, until the PC market it exploded. And then suddenly the understanding that networking technology was absolutely fundamental to the potential of the future of a digital economy became clear. So these are these things we call, in my field, we call these the reverse salient. This is this point, this bottleneck, or this point which is preventing emerging technologies being taken up. And really these security problems that have been so carefully and clearly explained today by the others are what is standing in the way of our future digital economy of technologies like, well, full implementation of the Internet of Things, or safety critical systems like connected autonomous vehicles. We have to crack that cybersecurity nut. And for any business leader who works in the future of secure solutions, I mean, this is sort of maybe not the ground floor, because we've had 10 years of work on this, but it's certainly one of the lower floors, the early opportunities to be involved in something that could be really transformative.
Thank you, Madeline. I'd like to turn to Richard again, if I may. We've heard about the promises, if you like, quotes unquote, or the potential of this foundational technology. And one would think, what about performance? Doesn't security slow things down, Richard?
Well, I think you've got to recognize that actually people currently do an awful lot of things for security already. So they're already actually paying quite a lot of performance cost. And so actually, if we can simplify some of that and make it easier to do, it can end up speeding things up. To take the compartmentalization story a little bit again, as being one of the big areas of research that I think we're going to get out of this program. We know that people currently use essentially a process-based compartmentalization. That is, you take your web browser or your mail tool that Robert was talking about and split up what it's doing into lots of different processes, and essentially use a lot of interprocessor calls to go between these different processes. And those add overhead. They put pressure on things like the TLBs. There's a lot of page table manipulation got to done. There's a lot of actual software overhead going on in order to do that compartmentalization. The promise of the compartmentalization that you can do through the Cherry technology is that you end up with being able to do it cheaper. So actually you could get the same level of security as we get today at a lower performance cost. So actually things go faster, or you can use it to have more security at the same performance cost. So actually, yes, there is a cost to security compared with leaving things wide open, in the same way as when I go out of the door or come back home in the evening, I have to put the key in the door rather than walking straight in. But that's a security cost I'm prepared to pay, because performance cost in my life that it takes me time to get through the door, because I don't want people walking in and out of the door. It's just part and parcel of it. And what we're trying to do here is actually make it actually easier to use this, and that will actually in some cases improve performance. But equally, other places you may find security is paramount and they're prepared to pay the performance cost. So I think there really is a range of different ways this can be used. It might consistent with what Madeline was talking about, there can be situations where, frankly, if we don't get the security right, people will simply not use the technology, and then the performance cost is entirely acceptable. In other places, we can effectively give similar or slightly better security than we get today at a lower performance cost than people are currently paying. And also we also know that people do all sorts of weird things under the hood in an ad hoc way to provide security, that again, this will systematize and people will find it perhaps more productive, and the cost will be pretty small. Robert talked about what the general performance cost is, for substituting all of the pointers with capabilities. That sort of 0 to 5% was in his slides. But you don't need to sort of take that away and say it's an absolute given. There's a lot more experimentation. That's part of the reason we want this board to be available, is so that people can really tell us, does this work compared with what I would be doing otherwise?
Yep. Thank you, Richard. Matt mentioned earlier about memory safe languages like C# or Rust. I'd like to ask Paul, where does this technology stand against that promise that we're going to solve our security problems of this world through memory safe languages?
Well, I think there's a couple of different ways of thinking about it, and Rich has just done a great job of explaining the tools that Cherry and capabilities give us hardware options to provide some of those memory safety options at a very high level of performance, and perhaps even better alternatives to what we're currently doing, and giving people the option and the sliding scale of, do you want more security or do you want the same security as before, but with a lower performance cost? And the same kind of things come up with choosing languages and balancing a choice of which language to use versus whether you want the hardware protections or the software protections, or indeed both. Cherry seems to provide extra options in terms of compartmenting code, and that contributes to resilience as well as safety from security bugs. Makes things easier to maintain and to analyze. There's a lot to be said for doing that. Also, I think has been discussed earlier, there's a much lower overhead cost in adopting Cherry in legacy code than there is in completely rewriting it in a new language. And there's a huge amount of legacy code out there, which, for good or ill, we are going to keep using and we're going to keep seeing across our society in places where we really need to care about its resilience and security. And so in some cases, the right thing to do is going to be to go straight in with new hardware. Of course, the safe languages have a place, and I think there's a lot to be learned, as Richard's been saying, about the best ways to use these tools. And the panel, I don't want to put words in their mouths, but I think we are convinced this is a force for good, and there's a huge number of benefits that we are already aware of. But we look forward to researchers and developers uncovering more as new products take shape and reach the market.
I would just quickly, if I can just quickly come in, having been, working in for ARM actually for the best part of 25 years, the number of times I've been told, oh, you don't need to worry about this. The new language will come along and you never have to worry about these problems. I've heard that for about 25 years, and it doesn't happen. People carry on using the existing skills, the existing language, the existing code, and they all have a place. It's not, we're going to have better languages and we're going to have better hardware, and you need to have both, in our view.
Thank you, Paul. Thank you, Richard. I'd like now to come closer to Madeline's expertise in a way, and to ask Madeline, what's the role of policy in motivating discussions about such foundational technology?
Yeah, I mean, that's always been a role of governments, frankly, is where we see a kind of market failure, which was described by John in the beginning, that the governments do have to step in and they have to create some kind of initiatives, very much like that case of the internet or email was another one where, really in the 80s, the US government tried very hard to get the US postal system to commercialize email, a bit because they saw that as intrinsically linked to the delivery of physical mail, but the US Postal Service didn't see that opportunity, and the government had to sort of continue to try and find an opportunity to commercialize that. It's a very, there's a very long legacy of governments taking that role, either to try and stimulate it, by demonstrating a business case, or by other mechanisms. And now we're seeing really like quite a change in the digital economy, where governments in places like the UK, the US, Australia, the EU are beginning to take this more proactive regulatory approach, where they're really defining where liability for breaches lie in the business sector. So both, specifically for senior business leaders and for board members, but also for organizations themselves. So we're seeing this shift from this kind of do your best to now much more of a regulatory heavy hand that imposes fines. And then we're also seeing this shift from individuals that are increasingly sensitive to the misuse of data and to safety issues that arise from engaging with insecure technologies. So where in the past, people really just took that for granted and kind of learned to live with it. We're seeing that change both from a consumer perspective and from a business, from a government sector. And so that makes this very much a business issue then, because as I said, the future of any digital economy will rely on a willingness and an ability to implement emerging technologies. And some of those, just the security issues and the safety critical issues will be prohibitive. So for those, business leaders who are thinking to not just the cybersecurity problems that we encounter now, but what could we open up in the future if we thought more creatively and more broadly about cybersecurity? The kind of the sky's the limit, really.
Thank you, Madeline. The other point, Paul, is for those technology businesses that are too busy developing their solutions at the moment, this technology might seem far out in terms of their future roadmaps, right? So what are some of the standing barriers for them, for those technology businesses to see this opportunity and understand this opportunity now?
Well, it might be far off, but it is coming, and part of what we're doing in the Digital Security by Design Challenge and the surrounding community is kind of preparing the ground for it. There's a range of activities being undertaken at the hardware level, as we've described, but also looking at the tool chain and the compilers, and more of these technologies will be coming online. And so it kind of depends where in the technology stack these businesses sit. But in terms of low-level developers, the technology primitives are there now and should be part of people's research horizon scanning activity. We're looking forward to getting the development programs underway to investigate uses of these technologies. There will be some where it's not quite time yet, but actually proactive, forward-looking businesses who are looking to exploit, as Madeline said, emerging technologies and new types of business will need to realize that if they don't have customer confidence in their technologies, that things are not getting deployed. As regulations do get more heavy-handed, or more transparency is required in which security mechanisms are implemented and how they're supported, people are going to need to be able to show they're doing the right thing and using the most resilient technologies available. And so they need to be considering all of the options, including this.
Thank you, Paul. And extending that to John. So John, from your viewpoint, what are some of the elements of success, if you like, for the program Digital Security by Design? And what are you already doing about those for this technology to succeed?
Yeah, so I'd start by recapping the vision of the program. It's sort of twofold: to overcome the market failure, this problem of how do fundamental technology changes of this start into the supply chain, because hardware software is interesting because it takes many years to get a new hardware architectural design out, but I can write a new piece of software next week. How do you align those two things in terms of getting it through? So I think success for the program is that the answer, does this hardware concept work, is probably the main success factor. Can there be enough evidence to show that it's both secure, but it's also, we've heard about the performance questions, the opportunity questions. Are those answerable within the next year or so? And that I think is the key part of this. When we look out to what success that means, then really that's where what Madeline was describing, not only in the application sectors today that we need security and resilience, but if people, the problem at the moment is there's so much bad press around security this, security leak that, ransomware that. At what point do people actually shy away from using digital technologies? That I think that would be the biggest opportunity we have, is that doesn't happen. Okay, we can actually go out and know that our data is private, know that our bank account's safe, know that our computer's not going to be locked up and I can't open the doors anymore because the key doesn't work. So I think that that's really where the success is. But the program itself, as you've heard in the last hour or so, it's around getting the technology out there, understood, making sure the businesses understand the opportunities they have to actually make security a differentiating feature in the delivery of their products. You know, today we hear, you know, hardware agnostic, and security, really, cybersecurity is a problem for the user of the system, not the developer of the system. Okay, so let's move that, try to move that needle towards making sure that the solutions are by design and configured by default, so that the user still has their protections at the point of use, but they're not having to run around on a day's notice when a vulnerability pops up. You know, that the cost of that just must be astronomical for businesses. One, to have them on staff. Two, oh dear, we're going to have to turn off all our computers because one of them got infected. You know, that kind of disruption to productivity. Those are the challenges that I think the program hopefully will open the doors to resolving.
Thank you, John. Madeline, when we think about senior executives, right, board level, what would it take for them to appreciate this opportunity presented to them?
I mean, I think, you know, business leaders are always looking for a risk to exploit. You know, the idea that, as John said, this kind of, you know, business as usual supply chain is not something that every sector or every industry could be even contemplating disrupting. This is a major issue. At the same time, it's a huge risk to be exploited, because what kind of business as usual supply chains absolutely must function, and where are the opportunities to develop solutions for those supply chains so that it can be ensured that they do. Because at the moment, there are very few supply chains, if any, really, that aren't vulnerable to these kind of threats and disruptions. So in my mind, it's those kind of business leaders that are looking at cybersecurity as a risk that some businesses cannot tolerate, and therefore, what are the opportunities for technology like this to develop a solution to address those kind of issues that are intolerable? And this is very much in this context of, you know, business leaders being increasingly liable, personally and professionally liable. So in so many sectors now, you know, senior business leaders are looking to understand how can they shift that liability. Insurance is becoming increasingly difficult to write, because it's so difficult to quantify these threats and vulnerabilities that insurance companies really are becoming increasingly reluctant to write policies on this. And yet senior business leaders are becoming increasingly liable. So there's a huge market out there, really, to address those insecurities of senior business leaders by developing more secure solutions. And as we've heard today, after 45 or 50 years of effort in cybersecurity, we are where we are. And perhaps, in large part, the effort has gone on software solutions. And this is an area that we really haven't developed anywhere near as far as we need to.
That's great. Thank you, Madeline. John, I'd like to turn to you at this point. Earlier, Robert alluded to the fact that this technology is attracting interest from overseas organizations, not least DARPA's interest as well. Would you like to take us through some of that interest that's happening overseas?
Yeah, I think there's a couple of things to say on the scope of the program and the scope of the technology. The technology is obviously global. Okay, we are talking around basically changing the digital world, and the world being the big thing we all live on. Yeah, the program DSDB is obviously UK focused in terms of the aspects and the partners it's working from. We work with the UK registered businesses, etc. But that doesn't mean that we don't have global interest, whether that's through arms partnership. They obviously have partners throughout the world that are looking and monitoring this, so there's clearly international there. And then on the research side, we have, I think DARPA's actually mentioned that they are looking at this technology as well and reaching out to their partners in terms of providing access to the technology. So I think it really depends on how global you think it is. Obviously, there is a limited number of boards, so we're not doing this everywhere. But clearly, the importance and the relevance of the international part of this is key to its global success.
Yeah, if I can just echo that. I mean, the original announcement of this did talk about, in particular, Microsoft and Google being significant backers to the program, and they are putting in a lot of their own research efforts around these boards because, frankly, we need some of these big ecosystems, such as Android and so on, making use of this technology to really to reach that vision of ubiquity that we've been talking about throughout this session. So there are definitely quite a lot of international partners through ARMS connections as part of this. This particular access program we're talking about today is very much UK focused.
Thank you, John. Thank you, Richard. Starting to bring in some of the elements from questions from the audience. There's a question about whether Morello will be exploring low power requirements, Richard.
Yeah, I mean, we've actually got, for those of you who are familiar with the ARM architecture and the products that we provide, we have multiple profiles. We have the A profile, which this thing's based around, which is really aimed at perhaps bigger compute systems, and we have an M profile. We have a prototype of an M profile version of this in development. It's got slightly different constraints because they tend to be 32-bit architectures, and so the way that you encode a capability is a bit different. But we're very much looking at this. We do see this as being important for the Internet of Things in the sort of sensors and in all of these little embedded devices, as well as in the big computers. And so absolutely, we're looking at this in that context. And I know that Cambridge have been involved also with other architectures on this. I think they've done some stuff with RISC-V in this area as well. So yeah, absolutely. This is not. You shouldn't leave this session with a feeling that this is a big iron technology only. This very much scales down to low power systems. The research platform that we've created in this situation is there for larger systems we talked about, but it doesn't stop the learnings from it being applicable all the way down to the smallest servers, smallest sensors and actuators.
That's great. Thank you, Richard. I'm mindful that we are nearing the end of this panel discussion. We've taken questions from the floor. Just as we wrap up, I'd like to have from you, from your side, in a few sentences, what do we want people to think about this technology? What would be the key message from today to take away? Let's start with Madeline first, perhaps.
Yeah, thanks. So yes, for me, the key messages would be that we're at, I see this as an incredibly exciting point. This is very much the emergence of a potentially transformative technology. And for business leaders who have the kind of vision and foresight to understand how that will impact in the future and what kind of potential that opens up for a digital economy, for transforming society. There's this incredible ecosystem here with this huge investment from government in the research community in the UK, from really significant support from the private sector, from ARM, and this incredible opportunity to be involved in something that's happening now. And for me, it's an exciting opportunity.
Thank you, Madeline. What would be your message, Paul?
Well, I would echo that. I think there's an opportunity. There's been a lot of investigative research into the technology and development. So kudos to the team at Cambridge and all of the people that supported that work. Also a huge amount of work by ARM and other tech companies in kind of preparing the ground. There's clearly a lot of confidence that there's some really important use cases for this, but also that there's further uses and further opportunities that maybe more than we can imagine. Richard started to talk about different ways of reducing harm and also of interesting ways of balancing performance and security. And I suspect we really don't know how deep that seam can be mined for interesting operations and new ways of doing things. So what I'm really keen to see from this program is people exploring what can really be done with the technology. You know, we know it's good, but what are the limits? What are the really interesting applications that we don't even know about yet? And I really look forward to seeing those from the Access program and from innovative people exploring what can be done with something really cool that some of our finest minds have collaborated to produce.
That's great. Thank you, Paul. What about you, Richard?
Kind of much the same. I mean, I think this is a fantastic opportunity. We're really proud to be involved in the program. We're really fascinated about how this technology will be used. We've put a lot of work into creating these boards. The saddest thing will be if they don't get used and everyone goes, oh, that's rather interesting. It's a nice ornament on the shelf. We want to see these boards widely used, and this event is all about, describing a technology access program. And the real takeaway I want from people is use this opportunity to participate, to work with ARM, to advance security, because as Madeline talked about, almost the limits of what we will do with computing will be limited by the degree to which people trust the systems they work on, and security is a huge part of how society will change because of computing. I think this is a step towards making computing safer, more trustworthy, and really important that people take the opportunity to learn more and help us understand it better.
Last but not least, John, what would be your few words for the takeaway?
Yeah, I think the businesses are at a decision point. We've heard the technology, you've heard the belief of the technologists that there's something good here, and now you need to make a decision. Are you going to sit and wait, and it might show up again in your inbox as something, or your product was hacked, or you're going to start investigating what it means to your products and services so you can be one ahead of the people that are suffering in the new world?
Thank you, John. I'd like to bring this panel session to an end, and thank you very much for this excellent discussion. Thank you all, and thanks for the audience for their questions as well. I'd like to hand back to Dana at this point.
Thank you to this insightful discussion, to all the panelists, and to our chair.